Identifying functions. Remember that we have seen relations can be represented in a number of ways. A set of ordered pairs, we can use an arrow diagram, table of values, or we can graph it. A quick way to determine whether or not a relation is a function is to use the vertical line test. You may want to write this down, this next little part, and call this the VLT. The vertical line test. If it is possible to draw any vertical line on your graph that passes through two or more points, then the relation is not a function. So here's the way they describe it. Place a ruler vertically on a graph. Then slide the ruler across the graph. If one edge of the ruler always intersects the graph at no more than one point, then the graph represents a function. The two ways that I have explained it are identical. Example 1. For each relation, determine whether the relation is a function. I'm going to task you with something that is going to use your imagination. Is it possible to draw a vertical line so that the vertical line passes through two or more points? The answer is no. So therefore, we have a function. Visually, I can draw an infinite amount of vertical lines here. Now I'm just drawing a finite number of vertical lines. And what I see is that every vertical line passes through 0 or 1 point. So therefore, this is a function. And it passes, why? Because it passes the VLT. The other way of explaining it, as long as you could draw a vertical line so that the vertical line intersects at no more than 1 point. So for instance, if I draw a vertical line here, if you notice, no matter what vertical line I draw, they're going to pass through no more than 1 point. So therefore, it is a function. So determine if the relation is a function. Yes, it is a function. Determine the domain and range. So the domain and range are going to look like this. Now, I guess I suppose I should probably try to determine what each of these tick marks represent. From 6 o'clock to 18 o'clock, we know that's 12 hours. And if I'm counting up in 4 tick marks, 12 hours divided by 4 tick marks, that implies that each tick mark is worth 3 hours. Therefore, to write the domain, 1 tick mark before 6 o'clock is 3 o'clock. This next point is represented by 6 o'clock. This next point represents 9 o'clock. This next point represents 12 o'clock. This next point represents, well, it's 1 tick mark before 18 o'clock or 1 tick mark after 12 o'clock. It's 15 o'clock. 1800 hours. 2100 hours. Now, some of you guys are going to strongly object to this one. I'm going to call this 2400 hours or 24 hours. Generally speaking, this could also be written as 0 hours. The range of this function now, so those are all the possible inputs for my function. The range, I'm just going to try to draw what each of these values are. And it's just really estimating what are the y values. So my range is 5 for this point. And I'm going to go from lowest to highest. My range is 5. There we are. For this point, it's 6. For this point, that looks like it's 11. That point looks like it has a y value of 12. This one is 16. Up there, oh wait, this point also has a y value of 16, so no need to double write that. That next one right here is going to have 18, and this one looks like it's going to be 22. So there's my range. Now, determine whether or not this is a function. So if I draw a vertical line test, is there a way that you could draw any vertical line so that it passes through 2 or more points? And yes, if you draw this vertical line, what you notice, it passes through this point and this point. So I'm just going to draw this vertical line right here, hopefully. Come on. Vertical line right there. Oh, wait a second, also right here. So we have another point. Right, I'm just going to write not a function for B, because it fails the VLT. Fails the vertical line test. And maybe I'm going to explain why it does in another way. Let's take, for instance, when I have an element of 60. What I see when 60, when I'm given a height of 60, I don't know if it's this one or could possibly be this one. So for an input of 160, there is actually 2 outputs of different heights. So that's why it fails the vertical line test. Now, the domain and range is rather difficult here, but again, the domain and range. So it looks like I have to start over here, and each tick mark represents 10. So it won't be exact, but I think that's 158. And then I notice I have 2 points at 160, and I have another one at 163. And then I have another one at 106, or 2 of them at 165. So I'm done with all of those. Here it looks like 170. And this one here is going to look like it is 172. And then I have these 2 points, which is 175 and 180. So those are all the numbers in my first set. And then all the numbers in my second set will be as follows. Well, now I'm going to look at the vertical. So it looks like this is 47, and you might be disagreeing with me here. That looks like it's going to be 51, and it looks like I have 2 53s. If you notice, I just write 153 once. And it looks like I have a 54. Ooh, nope, I messed this up, right? So 53s. That looks like a 55 and a 57, but it's really hard to tell. I have 2 60s, right? 1, 2. It looks like I have 2 63s. Maybe I might even have a 68 and a 70. That would be the range. I think what's really important is that there's more elements in the range. And anytime you have more elements in the range, it is not a function. All right. Let's earn our money today. C. Now, is there any way that I could draw a vertical line so that it passes through 2 or more points? So if I just draw a whole bunch of vertical lines, what I see is it is impossible to sort of graph it is impossible to graph a vertical line so that it passes through 2 or more points. This is a function. And get used to, can you imagine a vertical line so that it crosses the graph more than twice? No. So then it is a function. So I'm just going to write passes VLT. All right, domain. Domain is going to be fairly tricky here. But domain, what we have is I have an x coordinate. So domain I describe in the following way, and range I'm going to describe in the following way. The first thing that we have to do for domain is we have to describe the variable x, and with a vertical line here. And that vertical line means exists such that. All right, that's good. Now, what is the domain? What are all the possible x values? Well, all the possible x values, if you take a look, my graph has an x value here at 5. And then it has it at 4, at 3, at 2, 1 at 0, -1, 2. And in fact, at all points in between. So we notice that the domain of this function really can be anything. Well, it can be anything that provided that it's lower than 5. So what we say, x exists such that x is less than or equal to 5. And that's my domain. I'm going to put where x is element of the reals. So here, I'll go over domain. This is what variable we're defining. X exists such that. This is the rule that allows us to enter this domain. So you can come in as long as x is less than or equal to 5. And here, this is the number set in which x belongs to. So x can be an irrational number, a rational number, it can be anything. It really can be any real number. Range. Now, range is a little bit more difficult. Range. Can the range be 4? No, the function doesn't go up to 4, right? So range can't be 4. So here, I'm just going to think horizontally. So what we see is that the range can be, well, I can have a y value of -4 as well, and also going all the way down because my graph goes on forever. In fact, I can have a y value of all of this, right? For 0, I have a y value. For this point here, I have a y value. And for every point in between, I have a valid y value. So really, what would I like to say here? I would like to say that the highest that y can be is 2, and then it just gets lower. So range, y exists such that, well, y is less than or equal to 2. Now, what number set does y belong to? Y belongs to the real numbers. And real numbers simply means any number. All right. We are almost there. I promise. D. Is D a function? Can you imagine a vertical line that passes through 2 or more points? No. So this is a function because it passes the vertical line test. The domain. Well, for the domain, really, x can be, this is the highest value for x, and x just keeps on going in this direction, right? So really what we would like to say is x exists such that, well, x is going to be element of the reals, but what is the rule to get in? Well, the rule to get into this domain looks like x has to be less than or equal to 3. my range is going to be a little bit different. My range is my lowest value for y. It's going to be -1, and y just goes up. So how do you say, well, my y value can go from negative, or is -1 and all the way up? Another way of saying it is y is greater than or equal to -1, where y is element of the reals. This is something that we're going to be working very hard, domain and range. If you have any questions,